Hello, I'm Nathan Yates with the Nortec Technical Services Department. Today we're going to talk about troubleshooting a refrigeration circuit using the job sheet. If you have any questions at any time, just click Ask a Question at the top right-hand side of your screen. You may have to escape out of full screen to do so. We'll answer your questions at the end of the presentation. Let's get started with what we call the job sheet. The job sheet is a document that we can have available for you if you need to. Within the document, there's boxes and places to put your pressures, line temperatures, your saturation temperatures, and it's an overall pictorial of how a system would be laid out. So visually, it's a good visual on how a system looks. Also within the job sheet is boxes to put your numbers in to calculate your superheat and your subcooling numbers for ease of use per the job sheet. So without further ado, let's take a look and see what we got today. The first job sheet we're going to take a look at is what a perfect world scenario would be. So let's take a look here. So right off the bat, our metering device is going to drive kind of what we're going to be searching for here. So for our examples, the metering device is going to be a TXV driven system. So with the TXV driven system, what you're going to use to verify your charge level is your subcooling. Your subcooling number is essentially your level of charge in your system. So just taking a look at some numbers here. For our outdoor ambient temperature, it's going to be 90 degrees. For our example, that's the first thing, or one of the first things that we ask techs in the field is, what's your outdoor ambient? Because that will determine what everything else is on our job sheet. So for our example, it's 90 degrees for our outdoor ambient. For our low side and our high side pressure, we're going to be rocking a 123 low and a 354 head pressure. What you will then do is take those pressures and convert them over to your saturation temperatures. So 120 for your low side is going to equal a 41 degree saturation, and a 354 is going to equal a 108 degree saturation. And those numbers are just getting them off a basic pressure temperature chart, or a TP chart. So what you will then do is take those pressures and the saturation temperatures and then look at what your superheat and your subcooling numbers are. So for our job sheet, we have it broken down. For our suction line temperature is 52 degrees. So it's 52 all the way from inside to outside, so we don't have a problem there as far as a restriction. So it's 52 degrees for our vapor line or our suction line temperature, and then our saturation temperature, which we got from the 120, is 41. So if you take the difference of those, you'll get 11 degree of superheat. TXVs that we have should maintain about a 10 to 12 degree of superheat, normally give or take about a degree or so. So I'm not totally strict on really when I'm troubleshooting a call that it's got to be between 10 and 12. If we're normally around a degree or so, we're fine. So about 10 to 12 is what you want to shoot for as far as a good number. For your subcooling number, again, this is the level of charge in the system. You're going to take your saturation temperature, which is 108, and then you're going to take your liquid line temperature, which in our case is 98 degrees on both sides of the dryer, so we don't have a restriction in the dryer. And you'll take the difference. So in our case, it's 10 degrees of subcooling. Your subcooling number should be anywhere from about the 8 to 12 degree of subcool. So we're right in the middle, but anywhere between 8 and 12, you're good. Usually give or take a degree or so. If you're more on the lower side, like the 6 to 7, you're probably going to want to add some charge to bring that number up a little bit, but 8 to 12 degrees of subcooling is what you want to see. So now another thing to point out is your delta T, or your temperature difference going across your indoor coil. And really how you get that is taking the difference between your return and your supply duct right across your furnace or your air handler. So for our example, we have a 73 degree return temperature and our supply temperature is 53 degrees. So you take the difference and it's going to give you a 20-degree temperature difference across your evaporator coil. A good delta T is going to be anywhere from about 17 to 21 degrees across your evaporator coil. So again, 20 degrees per our example is a really good delta T. So basically your delta T just verifies that I'm cooling the space well enough, that my supply temperature is cool enough going to my registers. So again, for a normal running system, a superheat number for our example is 11 degrees and our subcooling number is 10 degrees. The next system we're going to take a look at is what an overcharged system would be. This is also a common call that we get, is an overcharged system. Mainly it's because either guys are not weighing in their refrigerant or they're doing a gas and go basically, where they're just throwing refrigerant in and then leaving the job site, and then maybe they're getting a call back saying they're not getting, the customer's not happy as far as the cooling of the space. So let's take a look at what that could be. So for an overcharged system, for our example, we have a 90-degree ambient day for our ambient temperature. Again, our metering device is going to be a TXV, so we're going to be looking at our subcooling number for our level of charge. We have a 57-degree suction line temperature all the way through, so we don't have a restriction anywhere. Our liquid line temperature is 95 on both sides of the dryer, so we're good. So for a 90-degree ambient day, our pressures are going to be a 134 and a 405 for our pressures. Again, you'll convert the pressures over to saturation. So a 134 is going to be a 47-degree saturation temperature, and a 405 is going to be a 118. Then what you'll do is take a look at what your superheat and your subcooling numbers are. So your superheat number is going to be a 10, which is good. We're within range, 10 to 12. 10's okay. Our subcooling number is really high. We're way out of balance here. So again, the subcooling number should be about the 8 to 12 degree mark. So 23 degrees of subcooling, we're just stacking this condenser up way too much with refrigerant, and we're way overcharged. So what's happening is even though your superheat number is okay and your suction pressure is okay, it's a little bit high, but you're still okay on your suction, your delta T really isn't where it should be. 16 degrees is okay. It's a little bit on the low side. I normally try to get around the 20-degree mark as far as like a target mark when I troubleshoot with techs on the phone. And why the 16 degrees isn't terrible is because our metering device is a TXV. Because what we have here is we have liquid refrigerant coming down our liquid line and hitting our TXV valve, which you have to have liquid refrigerant in order for a TXV valve to work properly. So we're feeding the TXV valve with enough refrigerant to get it into our evaporator coil, but what's happening is that we may be forcing more refrigerant through our TXV than we should, which will give you a high suction pressure, which may flood your evaporator coil just a tad, which will drop your delta T, even if your airflow is set correctly. So for our example, what we would do is take some refrigerant out to try to get our subcooling number down between the 8 and 12 degree mark. That will probably have your delta T rise just a little bit by taking some of that refrigerant out. Your superheat number may not be affected at all. It might change, but that TXV, if it's working right, it should keep you around the 10 to 12 degree mark on that. But per this example, what we have is an overcharged system, so we need to remove some refrigerant. The next job sheet we're going to take a look at is what an undercharged system will look like. Let's take a look here. So for an undercharged system, what we'll point out first is essentially pressures. When a tech goes to hook gauges up to the system, first thing they're going to want to tell us is what their low side and what their high side pressures are running at the time. So for our example, we got a 90 psi on our low side. Our high side, we got a 273 head pressure. Again, per really how the phone calls go, is our next question is what's your outdoor ambient temperature? So for our example, it's 80 degrees for our outdoor ambient. Again, what will then go from there is we'll take our pressures and convert them over to saturation temperatures. So for 93 degrees, a saturation temperature is going to be 28 degrees for 93 psi. Your head pressure at 273 is going to be a 90 degree of saturation. So you'll use those numbers along with your line temperatures to get your subcooling and your superheat number. So for our line temperatures, what we got is a 44 degree suction line all the way through. So we don't have a restriction here. We checked it on the inside and the outside. So it's 44 degrees. Our liquid line temperature is 88 degrees on both sides of the dryer, so we don't have a dryer issue as far as a restriction. So then what you'll do is you'll take your line temperatures and your saturation temperatures and get your superheat and subcooling numbers. So for our example, our suction line temperature is 44, and we'll take away 28 degrees for our saturation temperature, which will give us a 16 degree of superheat. If we come over to our subcooling number, we got a 2 degree of subcooling. So remember, with the TXV driven system, the subcooling number is going to be your level of charge in your system. So you can already tell right off the bat that we're probably low on refrigerant. The 93 psi on your low side probably already told you that, or we might have a restriction somewhere. But by taking your subcooling number, you're like, oh man, I'm way low on charge for my subcooling number. So for this example, what you would then want to do is add charge. What'll happen is that this subcooling number will rise and your superheat number will go down. Again, your subcooling number should be about the 8 to 12 degrees of subcooling. Your superheat number should be about the 10 to 12 degrees of subcooling is what you want to shoot for. Now, when techs add refrigerant to the system, a lot of times what will happen is they will only read or only go off their subcooling number. They will not check their superheat. We always tell guys, even if you have a TXV driven system, you always want to check your superheat because that verifies that this valve is operating correctly. So with an undercharged system, what you will have normally is a subcooling number that's too low, a superheat number that's too high, due to the fact that we don't have enough refrigerant in our condensing coil, because remember, your TXV valve needs liquid refrigerant in order for it to work right. So what's happening is that we're not feeding enough liquid refrigerant down our liquid line to our TXV valve to then meter refrigerant into our evaporator coil. So the amount of refrigerant that we do have in the system that's actually getting to the TXV valve after it goes through the TXV valve to our evaporator coil, what's happening is that the refrigerant is boiling off too quick in our evaporator coil. So for example, it may be boiling off, say here, when it should be more, say, toward this area, for example. So what's happening is, again, it's changing state too quick, which is going to give you a high superheat number. Because remember, that superheat number should be about the 10 to 12 degree mark. So again, the amount of refrigerant that we're actually getting to this point, after this point, once it hits that fan on your return air temperature, you know, as your warm air, it's boiling off too quick. So what also will then happen is that your delta T will also be very poor. So a 10 degree of delta T, or a 10 degree drop, if you will, across your evaporator coil is too low. So you want to be about the 17 to 21 degree as far as your delta T goes. A 10 degree delta T is just terrible. So you're probably not even cooling the space whatsoever before the air, gets through your ductwork and then through your registers to your space. So again, on an undercharged system, what you will normally have is a delta T that's too low and a subcooling number that's also too low. So per our example, what we would then recommend techs to do is to add charge, get that subcooling number up to about the 10 or 12, retake your superheat number to make sure our TXV valve is working right. Your superheat number should come down. If it doesn't, then we have another problem. But your superheat number should come down, and then retake your delta T, and hopefully this number will increase. So those are the symptoms of an undercharged system. Let's take a look at our next one. The next thing we're going to take a look at is the restriction at a TXV. So this is a restriction in the system, and the reason why I picked a TXV is because the most common call that we have is a TXV not working properly. We get other calls as far as maybe a line set issue or a coil issue, whether that's the indoor or the outdoor. But just to kind of keep it straightforward here, I just picked the TXV. So let's take a look. So what we have for our outdoor temperature, just to get our parameters all out there, we have an 85-degree outdoor temperature. Our pressures that we're running right now at 85 degrees is a 123 low side and a 405 on our head pressure. Then what you'll do is then take those temperatures or those pressures, convert them to your saturation temperatures to get your superheat and your subcooling number. So when we take the difference, if you will, or the math, we have a 18 degree of superheat and our subcooling number is 23. Also, for our info here, our delta T is a 12, which is, again, out of range. That's terrible. So we're probably not cooling the space very well, if at all, at 85-degree ambient outside. Our liquid line temperature is 95, and then our suction line temperature is 60 degrees. So what's kind of going on here? So what's happening is that the TXV, whether that's the bulb isn't in the right position to begin with, or I have a mechanical failure at the TXV, something here isn't working right. So if you kind of just take a step back and take a look at what we got going on, our superheat number is far too high. It's 18 degrees. If you kind of take this number and also look at what your delta T is, those numbers kind of go hand in hand, meaning that your superheat number is too high. We're underfeeding our evaporator coil, which is giving us a poor temperature difference across our evaporator. Our subcooling number is crazy high, so again, what we're doing is we're stacking refrigerant in our condenser coil. So the refrigerant flow is just a cycle. We're coming down our liquid line, we're going through our TXV, through our evaporator, back on our suction, through our compressor, and then we're coming back to our condenser coil. So we're doing this whole big loop here, and what's happening is that you're stacking refrigerant on your condenser coil. Because remember too, your condenser coil is going to be bigger in footprint than your evaporator coil. Okay? So any extra refrigerant or any refrigerant flow imbalance, we're gonna stack it in our condenser coil. So with the restriction at a TXV, what's happening is that this is the point at which we're stopping the flow, if you will, of refrigerant. So again, the condenser coil is filling up or is storing all the refrigerant essentially in the system. We are still feeding liquid refrigerant to the TXV, which you need liquid refrigerant for the TXV to work properly. So we are good at that point. We are feeding the TXV, but what's happening is that TXV is not either, is basically not opening up as far as it should be. So generally, sometimes it's a bulb placement issue, or it's, hey, I didn't take the bulb off when I brazed, or it could just be a TXV failure because it's a mechanical part. So The superheat number reflects that, because what's happening is that you're underfeeding your evaporator coil. So that TXV should be maintaining about the 10 to 12 degree of superheat number, which we're not even close to that, and our delta T is way off, which should be about, again, the 17 to 21 degree, and our delta T is just terrible. So when you take all of this information into consideration, then what you're looking at is a TXV that is underfeeding your evaporator coil. That is the restriction in the system, and your charge level may be just fine, but you won't really know that until you fix this problem first and allow the refrigerant to then flow freely through your system. Obviously, when you replace a TXV, you'll recover the refrigerant. Then we recommend to then weigh the refrigerant back in. At that point, you'll know you'll have the correct charge amount, and then you can then re-troubleshoot the system. So again, we always recommend to weigh in the charge, so then you know you have the correct charge level. Then what you will do is then take your subcooling and your superheat number to basically verify that your system is working properly. So that's kind of how a restriction TXV issue would kind of look, for an example. The next thing that we're going to take a look at is what a low airflow is going to look like. This is a common problem that we have, that we come across when AC season starts up. It could be as simple as a dirty air filter that's never been changed. It could be a dirty evaporator coil. It could be a blower speed that is just not set correctly. But let's take a look at what a low airflow situation is going to look like per our job sheet. So just to kind of get our base of info here, the first thing we're going to take a look at is what our outdoor temperature is. So per example, 70 degrees is what we have for an ambient temperature. And as far as our line temperatures go, we got a 72 degrees for our liquid line and a 36 for our suction line. Our pressures are, we got a 100 psi on our low side, and our high side is rocking a 250 psi for our high side. Then what you'll do is take those pressures and then convert them over to saturation temperatures. So 100 psi is right at 32 degrees, so right off the bat we're borderline as far as freezing, if not freezing already. 250 is going to equal an 84 degree of saturation for your high side. Now, when you take those numbers and you want to convert them over to your superheat and your subcooling number, our superheat number is a 4, so we're low on our superheat. Subcooling number looks great, 12. So as far as the charge level goes, we're okay. We're not too bad. We are feeding liquid refrigerant down to our TXV, because remember our examples here are with the TXV-driven system. But yeah, the subcooling number is not bad. The superheat number, though, needs to be addressed. So when you want to take a step back and look at this, we are again feeding liquid refrigerant to our TXV, so we should be having the right amount of refrigerant for our TXV to work. But what's happening is that for your superheat number to be so low, per our example of a low indoor airflow, the refrigerant that's then feeding your evaporator coil is not boiling off quick enough, if you will, in the evaporator coil. So what's happening is that refrigerant, instead of, say, boiling off right here, it's boiling off like way down here before it exits back on your suction line, before it hits your compressor. So essentially what's happening is that your evaporator coil is flooded. That's what it is. It's straight up flooded at a 4 degree superheat. So for our example, a low indoor airflow will flood your evaporator coil, because essentially how you can look at it is that you're not getting enough warm air to go across your evaporator coil in order to boil off that refrigerant that's in the evaporator coil, say up in this area versus way down here. As a result of that, you'll also have a delta T that is too high. So your suction line pressure is 100. You're already rocking a 32 degree saturation in your vapor coil itself, so your delta T is going to be high. Also, with a low indoor airflow, your delta T is also going to be higher. So what you would then want to address is what's causing my low indoor airflow, which again could be a filter, a dirty evaporator, a blower speed. Those are the three simple things to look at. The one that, say, you might have to make considerable adjustments is your ductwork. So, but for our example, a low indoor airflow scenario is going to give you a high delta T. Your superheat is going to be low because you're flooding your evaporator, because you're not boiling off the refrigerant quick enough. And also your suction line temperature is also going to be a lot cooler. So just remember too, once you get that airflow going across your evaporator quicker, this number here is going to rise, which is then also going to affect your superheat number. So as far as the charge level goes, 12 degrees of superheat, you're fine, because then we're checking the TXV for our charge level. So again, a low indoor airflow, you're going to have a poor delta T, or in our case, it's going to be too high, and your superheat number is going to be too low. So those are the symptoms of a low indoor airflow. Thanks for joining me today. I hope you'll find this information useful in the field. Now let's answer some of your questions. All right, and we have some great questions coming in already. We're going to just roll through these, and if you guys have any other questions regarding the topic that we covered as far as the refrigeration system goes, the cycle loop, if you will, we'll be happy to hit all those questions for you. So just to kick it off here, we got a question from Tom. Question is, why do you look at superheat when you have a TXV for your metering device? So, because mainly you would go off of your subcooling for your charge level. So the reason why you look at the superheat number is to verify that your TXV is working right. So your charge level is determined by your subcooling, and then you'll look at your TXV for your superheat for your TXV to make sure your valve is working properly. So that's the main reason why you want to look at your superheat. Just verifies that your valve is working right on that. Okay, so we got another question here from Nick. Let's take a look here. What happens if you add charge to an undercharged system, but the superheat doesn't change? So actually, that kind of goes hand in hand with the last question. So if you remember from the undercharged job sheet that we did in the presentation, the superheat number was high. So if you add charge to a undercharged system and you get your subcooling number up, you want to check your superheat, because again, that verifies that the TXV is metering them properly. So if you take your superheat number and it doesn't change, then most likely is that I got a TXV that just isn't feeding my evaporator as good as it should. So, but yeah, so if you're adding charge to a system and your superheat doesn't change, you want to then check your TXV out. And that could be as simple as just taking the bulb off the line and just warming that sucker up in your hand to try to force that TXV to open up for you, which should change your superheat number. Okay, let's see here. Got another question from Kevin. Kevin asks, what if the liquid line temperature is lower than the ambient temperature? Okay, that is a great question. So your liquid line temperature should be at ambient temperature
or above. So if it's below ambient temperature, that can indicate that you have a restriction in your condenser coil. So sometimes if you have a system that is just very overcharged, if you will, your liquid line temperature can come down to ambient. It may be a degree under ambient, but if you're like 10 or 8 degrees or even 5 degrees below ambient temperature on your liquid line, that's a problem. So first thing that you want to do is take a temperature difference across your filter dryer. Obviously, make sure that's not the problem. It should be within 1 degree. Normally it's about half of a degree temp drop across a dryer, but if you're over 1 degree across a dryer, that's too much. But take a temperature on your liquid line from the outside to the inside, and it should be the same. Obviously, if you have like a really long line set, you may have a little difference, but it should be the same between the inside and the outside. But if your liquid line is cooler than your ambient temperature, that means you are metering refrigerant in your condenser coil, which will also affect the amount of refrigerant before it even hits your metering device inside. So good question. That should be at ambient or above for your liquid line. That's a good question. Let's take a look here. Okay, got another question from Joe. Joe is asking, how should the bulb be mounted on the suction line? Okay, so the bulb on your suction line, it should be mounted generally between the 10 and 2 o'clock position, is what we tell guys. You know, it could be, you know, like as much as the 4 o'clock position. Basically, you just don't want your bulb at the bottom portion of your line because that's where all your oil is and your refrigerant, and you won't get an accurate temperature reading if your bulb is on the bottom. So basically, you just want to make sure that that bulb, again, is really between the 10 and 2, or it could be as much as the 4 o'clock position on that, as far as that goes. Now, the placement on the bulb versus a horizontal and a vertical line, basically, if you can, you want to place that bulb on a horizontal line is most ideal. If it's on a vertical line, you want to make sure, I have a TXV bulb here, you want to make sure that the output of the bulb, if you will, is facing up. So if it's facing down, what will happen is that you'll basically push all the little bit of refrigerant out. It'll just turn to liquid, and it'll go through our little cable here to our TXV head, and it won't allow your TXV to work right. So basically, if you have to place it on a vertical line, which really you don't want to do that to begin with, you would probably end up putting it like on a diagonal line or I got a 45-degree angle. Just make sure that this outlet of the bulb is facing the upward position on that when you're installing your bulb for your TXV. Good question. Okay, let's take a look at our. Okay, a lot of great questions coming in, guys. This is awesome. So, okay, Jerry asks, with the microchannel coils, the most temperature drop we see are in the range of 22 to 26. Is this too cold of a coil? Okay, so yes, that is a little bit too cold. If you're more toward the 26-degree mark and above, yeah, I might have an airflow issue or a metering device issue. So that's why taking your TD along with your superheat and subcooling numbers will give you a good indication on where your refrigerant's at. That's what I like to tell guys on the phone is I got to know line temperatures because that's going to tell me where my refrigerant's at in the system. So it's not necessarily bad to have a 22 to 26 degree temperature drop across the coil. I mean, that's really good for for a TD across your evaporator coil. It is a little bit too cold, so I would be asking what is my suction pressure at that point, and knowing that bit of info. But yes, to answer your question, Jerry, it is just a tad too cold on that, so you may want to adjust airflow a little bit. Okay, let's see what we got going on here. A lot of good questions. Okay, Dan asks, where can we get the blank job sheet that the examples were shown? Okay, so the job sheet, I don't have a 100% answer on that. I'm still working with Doug, my manager, the tech service manager, on where we should put that at. It will probably end up on our tech literature library on our website, and I will suggest to Doug that we put that in multiple locations on that website, if not, at every heat pump and AC model that we put that on, or if it's just kind of like a generic place, something that's really easy to see on that, because I use them every day, because I'm a visual guy, so I like to get a whole layout of a system and get all my numbers right in front of me. As soon as I do that, I roll through a troubleshooting call pretty quick, as long as I have that job sheet. So it's a good, useful tool. So I use it every day. But I will get back with you on that, and I will get with Doug and then our marketing department to get that in a good location for you guys. So good question. All right, let's take a look here. Okay, so Jerry asks the information, or I'm sorry. Okay, so Jerry's just asking the information on the chart that we had. So I think by your question, the examples that I went through, I basically just kind of made those up, to be honest. I went through calls and notes and previous call tickets that I have worked with. I also went around the room with the other techs and went off their notes and just examples that we've kept and examples that I've kept just for my personal reference and just learning and all that stuff. So those numbers I basically made up, if you will, to give you each example on either if it's an overcharge, undercharge, and low indoor airflow, on what it will look like. Obviously, those numbers will be a little bit different out in the field, and again, that's all going to be really driven on your outdoor temperature, because that will change your head pressure and your load on your indoor coil. So basically, those are just numbers I came up with for an example on that, Jerry. Okay. A lot of good questions. This is awesome. Let's take a look here. Okay, so another good question here. If the TXV is restrictive, the suction pressure should be lower than normal, or will it be lower than normal? Yes, so basically a TXV, which is a metering device, that is the second brake in your refrigeration system for pressure differential. The other place is your compressor. If you have a heat pump, the third place is your reversing valve. But to answer your question, yes, if that TXV is restricting flow, if you will, your suction pressure, your suction pressure should be lower. I mean, I just look at it as a door. It's either going to open or close for you freely, and if that door or the valve, if you will, isn't opening, then your pressure is most likely going to be lower. So yes, a TXV that's not opening up all the way, you will have a lower suction pressure. Now, your superheat number will also reflect that too. So you'll probably have a higher superheat number because all the refrigerant that's even getting to your evaporator coil is boiling off too quick, and you probably have a bad temperature difference across your coil. So to answer your question, yes, it will. Okay, so question from Barry. Okay, Barry, I just touched on this earlier. His question is, where can we print the job sheet? Or can we print the job sheet? If so, where? Okay, so again, guys, I am going to work. I'll get with Doug on that. He's my tech service manager. I'll work with him on that and with the marketing department on where we can put that job sheet available for you guys. For me, it's a PDF file on my computer that we have, so you should be able to print them out or download them to your computers, or have the tech guys be able to pull them up on the job site. I mean, that'd be really good if we can have that going for the techs out in the field. But again, I'm going to get with really marketing department and see where we can put that in either a general location, or if we'll put it at each unit model that we have. So if you're looking through your tech spec, that's like the first thing you guys pull up on the tech literature library. It may be at the top there, but again, I'll check in on that because I know it's not as of right now unless it's changed recently. I don't think that document is on the tech library, but that's where it will be. But I'll make sure that's in a very readable spot for you guys, and it's right there. So. Yes, James asked a question. Are you going to do the same presentation using a piston? Yes, I would like to. So I would like to do the same thing that you just saw, but on a piston-driven system. Because normally when you have a piston-driven system, instead of looking at your subcooling number for your charge level, you'll be looking at your superheat. The superheat is what drives for your charge level in a piston-driven system because it's all load-based, basically. So yes, I know that this lunch and learn, if you will, is the last one of the season, but we are still doing tech tips every week. So I shoot those every month. So any suggestions that you guys might have, that would be awesome as far as topics that either you're not seeing or that you want to see, or kind of situations that you're coming across in the field that you're just not sure on, that, hey, this would be a good video, or anything like that. So yes, I do want to do a piston-driven version of this, which will probably, again, will be an actual tech tip video instead of a lunch and learn. But if you have questions over that video, you can email those to us to our tech service email, and I'll be happy to get back with you on that. But yes, I am going to work with a piston-driven system on that. So I picked a TXV version because most of the stuff that guys will come across is TXV driven, but there's still a ton of piston stuff out there. And then I know some guys like to actually just prefer piston-driven systems. So yes, I'll work on that and get a video for you guys on how that would look for a piston. Okay. A lot of good questions here. Okay, another question is, how can we validate refrigerant charge and heating? Okay, so obviously that is going to be with the heat pump. There's no way to really know 100% sure on what your charge level is with a heat pump in heat mode, because again, those pressures will change based on your outdoor ambient temperature, because you're soaking up the heat from outside and then throwing it inside to your evap coil. So there's no way to know your refrigerant charge in heat mode by going off pressures. The only 100% way to know your charge level is to yank the refrigerant and weigh it back in per the data plate on the unit. If you still happen to have the QRD from the install, I would also look at that. You can also find the QRD, which is your quick reference data sheet. You can find that on our tech literature library, which is off our homepage, nortechhvac.com. Because sometimes, based on your matchup, you actually have to add an additional amount of refrigerant per your 15 feet worth of line set. If you're after your 15 feet worth of line set, you will then have to add additional charge, depending on your line set length. But for heating mode, there are charging charts in the install instructions, and it ranges from, I believe, 0 to 60 degrees Fahrenheit. And you would basically just go off of that chart in heat mode. If you're going off on high head pressure, which can indicate that you are overcharged, and you're, say, pushing over that 60-degree mark, I would then probably pull the charge and weigh it back in, because you never know who actually has got their hands in it, and what the charge level is. So, good question. Just take the charge out, weigh it back in. Okay, let's take a look here. Okay, Ferris has a question. His question is, what about a low ambient fan control? What will the pressures be at these conditions? So we're probably talking about a low ambient kit would be my guess on that, as far as your outdoor unit goes. So there's no real hard numbers I could give you for a low ambient kit. A low ambient kit will help you along with your air conditioning, obviously, when it's cooler outside. Let's say it's like 60 outside, or it's lower than that. I mean, we've had calls when it's like 50 degrees outside and the people are wanting to run their air conditioner instead of opening a window. But how it will affect, basically it's going to help raise your head pressure on your high side, which will help the change of state in your condenser, is the easiest way to put it. Again, those numbers will be a little bit different based on your ambient temperature. I don't have exactly what it would be, or maybe a ballpark figure on what it would be. I'd have to get with the guys in tech service and kind of throw that around the horn and see what they might say on something like that. I'd have to get back with you on that, because I don't know 100% on what that would affect. So, or what your numbers would be on that. But basically, it helps with, obviously, when it's cooler outside and people want to run their air conditioner. So it just helps with head pressure. So. Let's take a look here. Okay, so Richard has a question. Let's take a look here. Okay, so I think per Richard's question, he's just wanting to know, I think you're wanting to know what a target head pressure would be. Okay, so because you're asking, can I use plus 30, plus 20, plus 10 degrees above ambient? Okay, so with a 14 SEER air conditioner, 410A, what you're going to do is you're going to do 17 degrees above ambient as a target head pressure. That's something I always point out on a phone call. It's like, hey, what's your outdoor temperature? They'll tell me it's 85, so I'll do 85 plus 17, and then I will then look on a temperature pressure chart and see what target head pressure is. So I will then tell the tech that, be like, hey, this is where we're trying to shoot around. Let's say it's 325 is target head pressure. And I'll usually give or take 10 PSI on that. It's not an exact science, but normally for a 14 SEER, you will do 17 degrees above ambient. That will give you a good number to at least reference when knowing if your head pressure is either too high or too low. If you're talking like older systems like R22, like 10 SEER, and like 12 SEER systems, I know 10 SEER for R22 is going to be 30 degrees above ambient temperature will be your target head pressure. So that's 30 degrees above ambient for a 10 SEER R22. I know that a 12 SEER should be, I want to say the 20 degrees above ambient for a 12 SEER. And then once you hit about 13, 14, there's really no big difference. So I just go with 17 because you're 3 degrees off difference between obviously 20 and 17. So you're not going to have too much variance there. So to answer your question, 410A, 14 SEER, use 17 degrees above ambient temperature. If you're rocking like an older R22 10 SEER, that'll be a 30 degree above ambient. And if it's a 12 SEER, it'll be 20 degrees above ambient on that. Okay, great questions, guys. This is awesome. Okay. Okay, Alvin has a question. His question is, can the job sheet be included in the install instructions and be used as a startup sheet? That is a great point. Honestly, I didn't even think about that. That is a great point. So I will put that down the pipeline as a suggestion that we should put that in the document for your install instructions for sure. Like maybe like toward the front, toward the back, or something like that. That'd be a good place. But yeah, that is a great point. That's awesome. So I will push that down. I will suggest that to Doug, which is our tech service manager, and see if we can get that in the works to put it in the install instructions. That's a great point. So I will definitely suggest that we do that. So, but yes, awesome. Okay, Jerry, yes. Jerry has a question. His question is, we didn't cover a piston metering device. Will you go over what we would see with a plug screen? Okay, so Jerry's question is if we had a piston-driven system and we had a plugged screen on your evaporator side. Okay, so on a system that is piston driven, obviously our focus is then going to change toward a superheat number, which the only way to correctly get something like that is to use a psychrometer. But basically, your head pressure is going to be a little bit higher on a piston-driven system because what's going to be happening is you're just going to be stacking refrigerant on your high side, and then your low side is obviously probably going to be too low. If you're under 100 psi, which is 32 degrees on your temperature pressure chart, you're already freezing, if not starting to freeze. So your superheat number is going to be high because you're going to be underfeeding your evaporator coil, and your low side pressure is most likely going to be low. So you'll have a high, it won't be too different from a TXV, in all honesty, because it's just a metering device. But your superheat number is going to be high, and your suction pressure is going to be low for something like that. So, and most of the time, if you let the system run long enough, you will go off on a high head pressure switch on something like that. Because eventually what's going to happen is that refrigerant that's going around in your refrigerant loop is just going to stack all of it into your condenser coil, and eventually, with the condenser coil being a micro channel, you'll probably end up hitting a high head pressure switch as a result. So that's kind of roughly what you would see on a plug screen for a piston. All right, great questions, guys. Okay, Dan asks, this is Dan's question. Do you have some suggestions on diagnosing poor airflow without putting gauges on and tapping into the refrigerant circuit? Using temperatures only. Okay. Okay, so basically we want to try to check airflow without getting gauges and putting them on the system. Okay. Let me think about this for a second. So I don't think there's a way. I'm trying to think of how I would be able to do that. I'd have to throw that around the horn in tech service. I don't know, Dan, on that. The only reason why I say that is because of your pressures are gonna tell you your saturation temperature. Because when you convert a pressure over to a saturation temperature, that's gonna tell you essentially how cold your evaporator coil is running at the time. Getting your suction line and your liquid line temperature is a good start, but not that I'm aware of that you can just take a line temperature and know if you got poor airflow. I don't know, to be honest. So I will have to get with, write that down. I'll have to get with the other guys in tech service and see what they say on that and see if there's any like tricks of the trade, if you will, as far as getting something like that. Because basically, at least for me, what I'm going to want is a superheat and subcooling number, which you can only get by hooking gauges up and taking line temperatures. As long as I have those numbers, you can pretty much troubleshoot any refrigeration system out there. So, not that I'm aware of on that. Let's see here. A lot of good questions, guys. Okay, another great question. What will happen if the TXV equalizer got a restriction? Okay. So probably what we're talking about here is this guy here. This equalizer tube right here that goes from the TXV, and this is with this particular TXV has got a mechanical fitting. This is a replacement. Let me get the TXV so you can actually see it. Is a replacement TXV, so it's got a little mechanical fitting that you actually screw onto your suction line on that. Great question. You know, I don't know on that. I would say send me an email at tech service and ask me that, Ferris, because that's a good question. I have not come across something like that to where if that equalizer tube were to get plugged with something. That's a great question. I don't know. And what I can do is if you send us an email to the tech service bin and be like, hey, I asked this question in the Lunch and Learn and Nathan wasn't sure. If you shoot me an email, I'll reply back to you, and I may touch on that on the next video that I'll do for the piston driven. I may just do that at the very beginning, just so I can have it out there to all the folks that are tuned in. Good question. I don't know, to tell you the truth. I don't know what that would do. I'll have to get back with you on that, though. Let's take a look here. So I'll give you guys about a minute here. A lot of good questions that you guys asked. I'll give you about another minute here. If you have another question, please ask. I'll be happy to answer it to the best of my ability on something like this, as far as the troubleshooting goes. One thing that, as far as I'm waiting on questions here, that I wanted to touch on, the TXV that I brought in is a replacement TXV. Now, sometimes, so we have our inlet and our outlet side. So your outlet side is going to be the mechanical fitting always. Your inlet side could be either or on something like this. So let me turn the TXV around here. So a little trick that we found, one of the tech service guys told me about, is if you get a TXV and you either got the wrong one or a service tech has, like, say, this TXV and they need a braze version of this TXV for your inlet from your liquid line, what you can do is you can stock this fitting. Let me put it in the picture here. You can stock this fitting on their truck, or you can give this to them in the store. This is the fitting on like a 14 SEER heat pump, where it's 3/8 for your line size, and then on this side, it's obviously the mechanical fitting that will screw on. So what you can actually do, this is kind of neat, is that if they don't have the right TXV, you can thread this fitting directly onto your TXV, and then boom, you got a braze connection right there. So that can be used like in a pinch if they have either the wrong TXV on their truck, or somehow they got the wrong TXV. If you have this fitting, which it is a part by itself, that you guys probably have on your shelves, you can just thread this directly onto that TXV, and then you got a braze connection right there. It's a neat little trick I learned. This little fitting here, part number, just I'll throw it out there. The part number for this fitting is a 664194. Again, it's a 664194. But this fitting you would find on like the 14 SEER heat pumps on something like that. But that's a great little trick that you can do. Also, if you get a replacement TXV, you'll get in the kit as well. This is a tap-in for your suction line, threaded connection. So if you're replacing like a TXV on a coil that was factory brazed, you can use this tap-in connection and braze it right in. As far as your equalizer tube, that's what it's for. It's your equalizer tube. All right, guys. Well, looks like we're about all of the questions here. So, great questions. I hope this Lunch and Learn helped you guys out in the field, and at least try to give you a baseline on what an overcharged and undercharged, a TXV that's restricted on you or it's not working right, or a low indoor airflow scenario would look like. I hope that Lunch and Learn was beneficial for you, and is beneficial for the techs out in the field for troubleshooting, because when you show up to a job, you want to make sure it's done right, correctly, because what you don't want is a callback. Those are the worst. So thanks again for tuning in today. Again, this was the last Lunch and Learn of the season. We will pick this back up. I don't know if we do any Lunch and Learns over the summer or in the fall. We'll pick this back up. But again, we're still going to crank out tech tip videos for you guys. So again, if you have any suggestions on topics that either we haven't talked about in a while, or stuff that you think needs to be updated, or maybe just kind of like random things that you guys hear from your techs out in the field, that you want us to cover, by all means, shoot us an email at our tech service bin. and I'll get that, and we can talk about that stuff for you guys. So again, thanks for tuning in today. I hope you guys have a great rest of your day. Stay safe out there.